All right, so okay, guys. The question that we're going to look at today is a matrix question. You know, this is one such question that comes in section 2 of your paper 2. All right. So we're going to take this step by step. Part A of this question asks us to write the equation in the form of AX equal to B. And guys, simply put, A here represents the coefficients of the unknown X and Y. So in layman terms, A is just a matrix consisting of all the numbers that are in front of X and Y. So to write A, 2 is in front of X, 5 is in front of Y, 3 is in front of X again in equation 2, and 4 is in front of Y, or the coefficient of Y. That's A. X represent the unknown. X and Y are the unknowns. Here we go. All right, and it's equal to B, and B represents what each equation is equal to. So equation 1 is equal to 6. Equation 2 equals to 8. So this represents B. All right, so we've done part A. So A, X, and B are matrices. A is a 2 by 2 matrix consisting of 2 rows, 2 columns. X, column matrix. And so is B. X and B, you know, they have 2 rows and 1 single column. So that's part A, guys. Part B, we're asked to calculate the determinant of A. Right, so I'm going to put back B here. Now the determinant of A, and that can be written between 2 columns. So guys, that's the symbol. And that represents determinant. Now another way you could write that is to just simply put DET as in the abbreviation for the word determinant and A beside it. Any one of them is accepted. So here is how we find it. You have to multiply diagonally and then subtract. And you ask diagonally, so you're going to multiply 2 times 4. So it's 2 times 4. Minus, and here's the other diagonal, 5 times 3. Here we go. 4 2s 8. 5 3s 15. All right, so 8 minus 15, that's minus 7. So the determinant is a negative 7. All right, so that's part B. Part C, we're to show that A inverse. So that A to the minus 1 there is a symbol used for inverse. Part C. How do we find inverse? Inverse A. So that's A to the minus 1. That means the inverse of A is equal to 1 over your determinant. Remember, we found the determinant earlier, which is -7. So it's 1 over -7 times the adjoint matrix. Now, you may asking, what is the adjoint matrix? The adjoint matrix is the rearranged matrix. How do we rearrange the matrix? We go back and look at the diagonals. So we have this here is the first diagonal that consists of 2 and 4. What happens with the first diagonal, people? They switch positions. So 4 will go where 2 is. And the other diagonal, the second diagonal, which has 5 and 3, they are multiplied by -1. And if you want to put that in the simplest term, all you're doing is changing their signs to the opposite, to their opposite. Because once you multiply by -1, you're going to get the inverse, opposite. So that means +5 will become -5. They're not going anywhere. They're not changing position. They're just changing signs. -3. All right. So 1 over -7 becomes what we call a scalar. So we're going to multiply each element inside the matrix, the adjoint matrix, the rearranged matrix, by 1 over -7. So 1 over -7 times 4 becomes 4 over -7. Good? Then we move on to 5. -5 times 1 over -7 becomes -5 over -7. Good? And then we move on to -3. -3 times 1 over -7 is -3 over -7. Good? And 2 times 1 over 7 is 2 times 1, so that's 2 over -7. Remember, our aim is to have it looking like this over here. So all we have to do, we're almost there. All we have to do is simplify. Here we go. So 4 over -7 is the same thing as -4 over 7. So the minus can be above, in the middle, or below. Good? And -5 divided by -7. And you remember the rule, guys. A negative divided by another negative should give you a positive product. So this -5 over -7 is the same as 5 over 7. Good, almost there. Same thing that happens here now. -3 divided by -7. Negative divided by negative give you positive answer. Good. And 2 over -7 is the same thing as -2 over 7. Since we want all the denominators to be positive. So therefore, we've actually shown that A inverse is -4 over 7, 5 over 7, 3 over 7, and -2 over 7. All right, D of the question. Use the inverse to solve for x and y. So that means you're solving simultaneously the linear equation using the inverse. So guys, you're using the matrix method. So at this point, x is equal to A inverse times B. So that's why it's important for us to find the inverse. And in order to find the inverse, we have to know how to find the determinant. So remember what x represents? It represents the unknown x and y. Good. It's equal to the inverse that we just found. So it's minus 4 over 7 5 over 7 3 over 7 and minus 2 over 7 to complete the inverse. All right, so we're going to multiply that by b, which is 6 and 8. All right, so we're going to go row times column. Row times column. All right, so this is our row. We're using the first row, the top row, times a single column in B. So here we go. Negative 4 times 6. Negative 4 times 6, that's negative 24, and it goes back over 7. So that's negative 24 over 7. Plus 5 times 8, 5, 8, 40. And that 2 goes over 7. So we have completed the multiplication using the top row. We're going to use the bottom row now. So 3 times 6, 3 6 is 18. So that's 18 over 7. Plus negative 2 times 8, that's negative 16. So it's plus negative 16 over 7. Almost there. So x and y equal to, so negative 24 plus 40 is the same thing as 40 minus 24, and that's 16 over 7. Right? And 18 plus minus 16. A plus and a minus there, guys, dissolve into a minus, right? So 18 minus 16, that's 2 over 7. All right, so clearly this result in fractions, the result can also be, so therefore, whole numbers. So in this case, this particular question resulted fraction. So you put back your answers fractions. So x at the top represents the top value, which is 16 over 17. You know, they can't go into each, 7 can't go into 16 evenly. So we're just gonna keep it as a fraction. So x is equal to 16 over 7, and y is equal to 2 over 7. All right. So there we go. X is equal to 16 over 7. Y is equal to 2 over 7. And we have solved a pair of linear equations, simultaneous equations, using the matrix method. Okay, guys, so take time out to go through this question again, and see you tomorrow when we explore another question.